So hi and welcome to the 7 days online training session on Google Earth Engine for remote sensing analysis. I am course coordinator and this is our full course content of 7 days. We completed all of the things within the 7 days and we already covered our 3 number of classes, and today is our 4 number of class. Okay, so today the 4th day course content, mainly in this time I will try to discuss about the air quality parameters. So mainly we discuss about that. So today is our 4th day and 4th day course content will be that. First of all, I will try to discuss about that how you can easily remove the cloud from your satellite images. So mainly when you want to work with the cloudy wet season or rainy season image, then you can face some cloud and haze from your satellite images. Okay, so this cloud and haze very difficult for when you want to make the land cover classification map using these images. Then you cannot get the right image of the, you cannot write the proper accuracy of your image of your land cover classification map, as well as you also did not get the right land cover classification map. So this is the first condition. When you want to make the land cover classification map, you must be remove your cloud from your satellite images. Then you can get the clear condition of satellite images and you can easily get the land cover classification map using these images. So today I also try to discuss about that, how you can easily remove the cloud from your satellite images. Then I also try to discuss about that the visualization of hill shade map. So mainly in this time here I talk about the DEM data. DEM data is the digital elevation model, and how you can easily using the DEM data and make the hillshade map, SOLP map, as well as also make the aspect map using the Google Earth Engine platform. I also try to discuss about that. Then I also try to discuss about the land surface temperature monitoring. So mainly in this time here I use the MODIS satellite images, as well as also I use here the Landsat images, okay, and make the land surface temperature monitoring and also make the time series chart. Then I also try to discuss about that how you can easily calculate it, the average, maximum, minimum, NDVI or any other indices you want to need the calculated the average, maximum and minimum. Then how you can easily calculate it this for this any specific region. Okay, so let's go. First of all, how to remove the cloud from the satellite images. So mainly in this time here I use the cloud marks band function. So cloud marks band function is that when you want to remove the cloud from your satellite images, and every satellite images has a cloud band, every satellite images has a cloud band or cloud marks band. Okay, so then first of all we need to work with this cloud marks band, and then we can easily remove the cloud and haze from our satellite images. Okay, so here you can see that first image, you can see this is the one of the satellite images. So this is the Sentinel 2 satellite images, and you can see this image has some cloud or white pixel value. This white pixel value indicating this is the cloud. Okay, so here you can see some cloud, you can see white pixel value, it's indicating the cloud. But when I use here the cloud marks band function, I can get the clear condition of the images. Here you can see this is the another image, but this image is the more clear than it. Okay, so in this time I also try to discuss about that how you can easily remove the cloud from your satellite images and you can get the clear condition of satellite images. Okay, so for this, in this time I simply go to my code editor and try to discuss about this. So for this I simply open my code editor and try to show you the practically, so that you can easily understand how to the remove from the cloud from the satellite images. So I simply open my code editor So in this time I want to work with the Sentinel-2 satellite imagery. So I simply search in the top of the code editor. So I simply search the top of the code editor and use here the Sentinel. Simply search here the Sentinel. Okay, then I can get all of the Sentinel image collection. Here you can see. In this time I want to work with this image collection, Sentinel-2 multispectral instrument. I want to use this. Okay, so I simply use here this image collection. Okay, so I simply import this image collection. Here I can get all of the information about this Sentinel-2 multispectral instrument level 1C, this data set. So I simply click to the import, or if you want you can simply copy this collection snippet or paste in your code editor. I simply paste here code editor, and then I simply take a variable and give the variable name is the suppose Sentinel-2. I simply put the variable name and store my Sentinel-2 image collection in here. Okay, so in this time I also need to import my shapefile or my region of interest. So we already covered this part, how you can easily import your shapefile or boundary shapefile. So in this time I simply import my boundary shapefile. So here I already imported my boundary shapefile. So I simply import this boundary shapefile and work with this. Okay, so I want to work with this shapefile for, suppose I want to import this shapefile for Dhaka. Okay, so I simply import my shapefile. Here you can see this is the shapefile, and this shapefile I already imported in my Google Earth Engine asset. So in this time I simply import. Okay, so I simply import and give the name is that, suppose this is my ROI. Okay, you can see I simply import my region of interest and also import my image collection. In this time I want to filter this image collection. So I want to filter, so I simply use a function. It's called the filter bounds function. So I simply use here the filter bounds. Okay, and filter bounds it intersecting with my region of interest. My region of interest is that ROI, and then I also use here the filter this specific time period. Suppose I want to work with this time period, I simply use here the filter date function and put here my start date and end date. So first of all my start date is that I simply put the start date is the I simply put the start date 2016, suppose 1st January, and end date will be that I simply put here the end date 2016 December 31. Okay, I simply put my date, and then I also need to filter this image properties. I need the image only for this image, which image will not be more than less than cloud pixel percentage 90%. So I simply use here the filter function, and then I simply use here the dot filter dot less than what, less than what. I simply put here my image properties. So I simply go to this image properties, you can see, and then simply click on this image properties, and here I can get the cloudy pixel percentage. I simply copy this cloudy pixel percentage and then simply paste here. In this time I want to need some cloudy image because I want to remove the cloud from here. So I simply use here the cloudy pixel percentage 90%. Less than 90% cloudy pixel percentage I want to need. So I simply use here the 90, and then all of the images I want to make the median images. I take the median images. So I simply use here the median. If you want to check how many images will be available here, I want to check it. So I simply print function, and then I simply call the Sentinel-2, then simply paste here and use here the size function. Okay, and then click to the run. So now you can see how many images is available for the region of Dhaka district between this time period, and this image is less than cloud pixel 90%. We find out this total size of image 60 60 images we can find out in here. And in this time I want to use the total 60 images and make the median composite. I simply use the median, and then it also clip with our shapefile. My shapefile name is that RY. In this time I want to show the result, so I simply use here the map dot add layer function. And can you guess it, what is your object name in this time?
Sentinel-2.
Yeah, Sentinel-2. I simply copy the Sentinel-2 and paste here, and then click to the run, and we add the visualization parameter later. So I simply click to the run, and I also want to focusing the center of the shapefile. I simply use at the map center object, and this is my ROI, and zoom level is the 10, and then click to the run. So this is the capital ROI, and then click to the run. So now you can see the images of the Sentinel-2 for this time period. Here you can see first time I can get the totally black color images. Okay, so in this, because I did not add any visualization parameter in here, so in this time I just simply use here the visualization parameter, and then I simply use here the different types of band combination. So I simply use here the band combination. So for this I simply use here the, you can see, yeah, you can ask me.
Yeah, why you use the median map instead of using the mean?
This function median.
Yeah, why you use median? Why you
Okay.
use mean map?
Okay, so in this time here you can see, in this time I can get total 60 images. Okay, and this 60 images is not capture this satellite at the same period of time, at the same period of this year. It will be not captured. It take the different time of the year. Some image will be captured the 1st January, some image will be captured the February, March, different time of the date it will be taken. But in this time I want to make the composite, and in this composite from the total 60 images I take the median value. From the total 60 images I take the median pixel value and create this composite. Okay, in this time this image is created from their total 60 images median value. When I want to use here the mean, then this it will be created this pixel value from their 60 images mean pixel value or average pixel value. In this time I want to create the median. So in this time this total 60 images create the median pixel value and get the images. Okay, so from the 60 images I can get the median pixel value result in this time in here, median pixel value result. If you want, you can also use here the mean, then you can get the from the total 60 images you can get the mean pixel value like this. Okay, any question, any doubt, you can ask me.
No.
Okay, so in this time I simply add here the band combination. Suppose I want to use here the different types of band combination. So in this time I want to use here the true color composite. I use here the red band, then green band and blue band, and then I simply stress the 98% and then simply click to the apply. Okay, now you can see we can get the natural color composite, and then I also click to the import, so that visualization parameter will be imported in here. Then I simply copy this parameter and paste after the object name. Okay, and I also, you can see in this time this image has the some cloud and haze. So in this time, here you can see this is the cloudy pixel. Also you can see some cloudy pixel in here. Okay, also you can see in this time also cloudy pixel in here. Okay, and there is a lot of haze in these images. So when you want to make the land cover classification map using these images, you did not get the proper result because this cloudy pixel is mixing, this cloudy pixel value mixed with the urban or built up region, then we did not get the proper result. Okay, so in this time, so that's why I need to remove the cloud and haze from the satellite images and get the clear condition of satellite images. Okay, when you want to make the remove the cloud from your satellite images, then we also need to work with this band. Here you can see this band is there, this band called the cloud marks band. Okay, this band called the cloud marks band. Okay, so and this band name is the QS60. Okay, so here you can see the description about the QS60. This QS60, it has the 2 bit marks, bit 10 and bit 11. Bit 10 is for the cloud and bit 11 is the cirrus cloud. Okay, so here you can see bit 10, it has also 2 bit 0 and 1. 0 identify there is the no cloud and 1 is identify there is the cloud present. Also you can see bit 11, here you can also find the bit 11, and in this bit 11 here you can see cirrus cloud. Cirrus cloud, it means that yeah, also you can see the 2 bit 0 and 1. So bit 0 is represented there is the no cirrus cloud, and bit 11 it represented there is the cirrus cloud. Okay, so in this time, yeah, you can ask me.
Last time you removed the cloud using one system. Why now we go to the database and see which one have cloud, which one don't have?
I don't understand. Please ask again.
I'm saying last time
Yeah.
you remove the cloud using one analysis, and why now you go back to the database?
So previous class.
Understand? Yes, the previous class you remove the cloud, you use one analysis.
So previous class we also complete this part.
Mm-hmm.
Okay. So today is your 3rd day or 4th day? Today is the 4th day class. Yeah.
Yes.
So 4th day class we so 3rd day class we complete this part for remove the cloud and haze.
Exactly. That's why I don't understand why you go back to the database. You understand my question?
So I don't understand clearly. So you can ask me that this class we've already done or not.
No. I'm saying the class is already done. Last time you removed the cloud without checking the database.
So last
So why
time
you don't use the
last time when you want to work with this the Sentinel-2 for making the NDWI.
Yes.
Okay, so
yes.
So we use at the NDWI. So that's why we don't need to remove the cloud from these images, because NDWI is not the classification of the land cover classification. Okay, so when you want to make the NDWI, then it's not needed for remove the cloud and haze. But when you want to make the land cover classification map, you must be remove the cloud and haze from your satellite images. So that's why you can get the clear condition of the satellite images. And land cover classification is the first condition is that you have to the clear condition of satellite images. Okay. In this time, and this is the same process for all of the data set, for Sentinel or Landsat. I also try to show you the Landsat. You can see all of the process will be same. When you want to remove the cloud from your satellite images, then you can see in this time there is the cloud pixel value. In this time I want to remove this cloud pixel value from my satellite images and get the clear condition of satellite images. Okay, so then you can easily understand. So here you can see in this time I use here this data set Sentinel-2, and in this time I want to use this band QS60. Okay, so this is my cloud marks band, and this band has the two bits, bit 10 and bit 11, and bit 10 it has the another two bit, 0 and 1. Okay, it means that 0 is the no cloud and 1 is the present cloud. Also you can see cirrus also be 0 and 1. 0 is present that there is the no cloud, and 1 is the means that it present the cloud. In this time I want to work with this band, and first of all I need to select this band QA60, and then I also need to select the bit 11 and bit 10 and bit 11, and then I set the bit 10 equal to 0, also set the bit 11 equal to 0. So it's means that there is a totally clear condition of satellite images. Then we can get the clear images from the satellite, and then we can easily work with this. So in this time, for this task I want to select this band QA60, then I want to select the bit 10 and bit 11, then I set the bit 10 equal to 0, also set bit 11 equal to 0, then I can get the clear condition. And this task I want to use here my function. I do this task using the function. So for this I want to create a function. So for this I simply take a function, and give the function variable name is that max to cloud. You can use any name, and then I simply put here the element name is the, suppose I can simply put the element name is the image. And then I simply use here the curly bracket, and in this curly bracket I put my argument. My first argument is that I want to select this band. I simply take a variable and call my element name image, then simply use here the select function and select my band QA60. Okay, then I also need to select my 2 bit. So I take a variable, I want to select the bit for the cloud, so I simply use here the cloud bit max. Okay, then I simply use here the 1 less than the bit value 10. Also take the another bit value cirrus bit max, and then use here the 1 less than 11. I simply take the bit value of the 11, cirrus bit value and cloud bit max value, and then I also need to use here the max function. So in this time I want to set this cloud bit max equal to 0, also this cirrus bit max equal to 0. So for this I take a variable and give the variable name is that max. Okay, and then I simply call my band name QA, because this QA is stored my QA60 band. I simply use there the QA, and then I simply use a function, it's called the bitwise end. I simply use there the bitwise end. Then I simply put here this bitwise end. What I want to use the bitwise end, I want to use here the cloud bit max. I simply use here, then I simply use here the equal, set equal to 0. Okay, I simply set equal to 0. So now it identify there is the no cloud. Okay, so it's identify there is the no cloud. Then I also need to select the another things for the cirrus cloud. So I simply use here the end function, and then I simply call my QA. This is my band name QA60. It will be stored the QA variable name, and then I also use here the bitwise end function, bitwise end. Then I simply call the cirrus bit max and paste here. After that I simply use here the equal to 0. Okay, so in this time here you can see I simply put this. Okay, so I simply use the end function. So what is the wrong in here? Equal to 0. Okay. Okay, so I use here the double dot. Okay, so now it is okay. So here you can see. So what I can do in here? So first of all, I select this image QS60. I select this image band QS60. Then I select the bit 10 and bit 11, and then I simply use here the cloud bitmarks equal to 0. Also use here the Serras bitmarks equal to 0. So it means that it identify the clear condition. I created these marks, and now I want to update these marks. So that's why I need to use here the return function. I need to use here the return function, and then I simply use here this function is that I simply call my element name image, and then I need to use here the update marks function. Update marks, this is the function. It will be marks, it will be update your marks which you created. So I simply call the marks function, marks variable name, and paste here. Okay, so now this is my function I created, and this function you can see this is the function. In this time I want to add this function with my collection. This is my whole collection. So in this time I need to use here the map function. Then I can easily connect it with the function, and it will be just I can get the clear condition of the image. So in this time I simply copy the same code in here from here, because I want to show you the two layer. First layer is the cloudy image, and second layer is the clear condition of the cloudy image. So I simply take the same in here, and then I simply put here the, suppose this is the Sentinel cloud free. Okay, this is my object name. I simply copy the object name and paste here, and I created this function. This function I want to add with my collection. So for this I simply use here this function is that I can simply use here the map function and simply copy the variable name of this function, marks to cloud. Simply copy and paste here. Okay, and then I simply put the layer name is that, suppose this layer is the cloud free, and also take the another, I can simply put here this is the cloudy image. Okay, so then we can easily differentiate the two images, cloudy image. So when I run this code, you can see what is the difference between the two images. So here you can see the two layer will be open in here. This is the two layer. First layer is the cloud free, and another layer is the cloudy image. So it will be loaded. Then we can easily understand when I use the cloud mask function what is the different image I can get from this cloud. Okay, so here you can see. Okay, so now we can see what is the condition of the clear images. We can get the totally clear condition of image. Here you can see first time you can see the two layer. So you can see this is the cloudy image, this is the cloudy image. Here you can see some cloud, also some cloud. Okay, so we can get the totally clear not it is, this image is not clear, it is a lot of cloud and cloud pixel value and haze pixel value. But when I want to use here the cloud free, here you can see I can get the total clear condition of satellite images. So I can get that total clear condition of the satellite images, and now I can use the satellite images for making the land cover classification map, or also making the any remote sensing work. I can easily do it using the satellite images. Okay, so here you can see this is the image for the cloudy image. Also you can see this is the clear condition of image. If you want, you can easily export this cloudy free image from the Google Earth Engine platform and work with this. Hello, can you hear me? Hello.
Network, my network is not bad. It's really bad here. I'm going to try it at home. So give me like 5 minutes because I'm not far.